Hello everyone, welcome back to my channel. In today's Power BI tutorials, we are going to learn one of the most important concepts every Power BI developer should understand, that is data modeling in Power BI. Many beginners focus only on creating visualizations and DAX measures, but the real performance and accuracy of your reports depends on how well your data model is designed. So in this video, we will cover what is data model, fact and dimension tables, different schemas available in Power BI, and we have different types of cardinalities which can be used while connecting these tables in Power BI, and what is active and inactive relationships in Power BI. By the end of this video, you will understand how to build a professional Power BI model that is scalable, optimized, and much effective. So the first topic, what is data modeling? Think of a data model as the foundation of a building. Just as a building needs a strong foundation, Power BI needs a well-designed data model to provide accurate reporting and faster performance. A data model defines how tables are connected, how filters travel between tables, how data can be aggregated, and how DAX calculations work. Without proper relationships, Power BI won't know how different data sets are related each other. So basically, we have different tables in our Power BI report. So how you can connect each other so the interaction will work accordingly. So if you have different tables, maybe you can say fact and dimension tables, you need to give relation between these tables. So one of the table will talk to other table and provide required information based on our data model relationships. So before we start the data model practically, we need to understand what is fact and what is dimension tables. So you know, right, we have two types of tables, which is fact and dimension table. So a fact table contains measurable business transactions like sales, orders, claims, prescriptions, shipments. So these are all the examples where we can say these are all fact tables, because these all tables have business transactions, like you can see different transaction with value and what date the transaction happened, or for which customer this transaction has been performed. So these kind of information, whenever you see in a table, that is called fact table. So fact tables store quantitative and numerical data, typically representing business transactions or events. Fact tables usually large and contain a significant volume of data. They are the central focus of any data warehouse or data mart because they hold the core business metrics. Coming to the dimension tables describe the business entities involved in the transactions. So, dimension tables help provide context to the data in the fact table and serve as the entry points for users when they want to slice or dice or filter the data in their reports. So, typically each dimension table corresponds to a specific aspect of business such as customers, products, time, geography, or employees tables. Dimension tables are generally smaller in size compared to fact tables. In detail, always these dimension tables support to the fact tables. If you see, fact tables will not have all the information other than main columns like business transactions. But if you want other information, like you need customer name, customer location, or geography, so you need to depend on dimension tables to bring all those attributes from dimension table to the fact table. So one example I can give here: if you have a customer ID in your sales table but you don't have the customer name, so you need to connect this fact table to the dimension customer table and bring the customer name from dimension table to your fact table. Similarly, you have the entity or a country code, but you don't have the country name or the location or the region. So using this country code, you can relate this table to the dimension table and bring all those geographical attributes to your fact table. And third example, I can say if you have a date in your sales table, but you don't have the physical year calculation, or if you want the quarter or month. So if you want different physical year period information, so you need to use the calendar or a date table and bring all those information when you connect this fact and the calendar table. So always dimension tables will have this kind of supporting data which always supports to the fact table. So first, before we start practical examples in Power BI, I want to show you the actual data and I want to provide some context regarding this data at a background. So if you see, we have sales Q1, which we can say a fact table because we have all the transactional information. We have the customer, what is the product name, and transaction date and transaction amount for the Q1. Similarly, we have sales for Q2. Basically, we have the region code, customer information, transactions for the Q2, and transaction amount. So these two are the fact tables, but we don't have any other information. If you want customer name or region name or country name, we don't have any information that is available in the dimension table. So if you see the dimension table for the country, here we have the country company code and the country. So this is the dimension country table. And we have dimension customer table, basically have all the customer name and customer ID. So if you want customer name, we need to bring the customer name from this dimension table after you provide a relationship to the fact table. Then finally we have the region table where you have the country, but you want to bring the region, you need to bring from this table only because this information is also not available in the fact table. So let me open the Power BI file and quickly load this data and see some practical examples. So I'll just select Excel because the data is in Excel now. So just select this and then it'll ask you what are the tables you want. I'll just select all these tables and transform data. So if you can see all the data is available in Power BI. If you want to do any transformations in this particular tables, you can do, or else we can just try to close and apply so that the data will come to the desktop. So if you don't have any transformations, directly you can use the load option at the initial screen itself and you can bring the data. So now the data has been loaded. So we can see all the information now. So we have all these tables, two fact and three dimension we have. Okay. So before we try to understand uh, the data modeling practically, we need to see uh, what is schema. Okay. So what are the different types of schemas we need to understand. So accordingly, we will build our data model as per the respective schema. As I mentioned, we have two types of schemas in normally we use while building the dashboards in Power BI. So the first one is the star schema. So what is star schema? Think of the sales table as the sun and all other dimension tables as planets revolving around it. Because the dimensions surrounded the central fact table like the points of a star, this design is called as a star schema. The star schema is Microsoft recommended approach because it is simple fact and fast and easy to understand. Most enterprise Power BI dashboards use a star schema for better performance and easy DAX calculations. Star schema is a centralized fact table surrounded by dimension tables, basically have a direct relationship from all the dimension tables to the fact table. So this particular model will not have any indirect relationships. So star schema is easy to understand and have better performance and recommended by Microsoft and preferred in all the interviews. Now let's say what is Snowflake schema. So let's say our customer information becomes very large and we want to reduce duplicate data. Instead of storing country, region and city details in a single customer table, we split them into separate tables. This creates additional layers of relationships because these dimensions branch out like the arms of a snowflake. This design is called a snowflake schema. While snowflake schema reduces data duplications, it introduces more relationships, making the model more complex and significantly slower than a star schema. So snowflake schema normally uses the normalized dimensions and less redundancy and better storage optimization, but it's not have easy relationships, always have more complex relationships and more joins required for the snowflake schema. So basically in star schema we can see the direct relationships from the dimension to the fact, but here we can see some indirect relationships to the fact. So maybe one of the dimension connects to the other dimension and that dimension will be connected to the fact table. So basically the third dimension will be indirectly connecting to the fact table. So this kind of a model is called snowflake schema. So let's see practically these two schemas how well we can develop in Power BI. So first let's build a data model using star schema. So to build a data model, always you need to go to this model view and then click on manage relationships. Then you can give relationships whatever you required for this particular dashboard. So I'll just click on new relationship and I have a fact table of Q1 and I will select a customer table. Then it considers the customer ID as a common column. Sometimes it selects a different column, but you need to make sure both has the same values or whichever is having that column you need to select. Then click on so if you can see it is showing many to many and both direction and active relationship. So you can see the cardinalities in this particular field where you can see we have four types of cardinalities, basically many to one, one to many and many to many. So whenever you're having a left table and the right table, you can say this top table is called the left table and this bottom table is called the right table. So whenever the left table having a multiple values and also the right table having multiple values, that time it considers many to many. For example, if you consider the left table having many and the dimension having only unique values, then it will be many to one, and both are having unique values, then it will be one to one. And on the left table it is having unique values and the right table having multiple values, then it will be one to many. Basically multiple values means same ID or same attribute is repeating multiple times, and if it is unique that means it's one, if it's not unique it's a many. So by default it considers based on the table structure what we have, but see here it is showing many to many, which is not supposed to be, because your relationship should not have many to many relationships, because one ID have multiple customers, then it creates duplicates and your values will not be accurate. So before you create any data model, you need to make sure these dimension tables will have a unique value, then only our cardinality will show many to one. So let's fix this issue first and then we try to come back to data model and then give the relationship. So I'll just cancel this and I'll see why the customer table having multiple values, which is the duplicate value. See here we have 7437 is the total rows, but we have a 7389 is the distinct values. So what I will do, I'll just go to home and transform data and come to customer table, and I'll just right click on this and remove the duplicates so that all the duplicate values will be removed at a backend, so that it to the front end desktop screen it will show only the unique values of the customer number in this dimension tables. We can do this transformation only in the dimension table because you cannot do this remove duplicates in the fact table because we have to keep multiple values in the fact table. So that is the reason we have to do always customer dimension table only, so that it will not affect any of your business calculations. Now let's close and apply this and then see if the duplicates has been removed. Yeah, so you can see here 7389 rows and also 7389 distinct values. That means only unique values are remaining. So now we will go to the model view and then go to manage relationships, click on new relationship and select the fact table first, then select the dimension table called customer and having all these two columns which is having the common values, right? Selected, correct. And now you can see the cardinality has been changed to many to one by default because always the data model detects the values from both these tables and gives the cardinality. And then we have two types of filters will be there: cross filter direction, single or both. If you are using any particular values from dimension to the fact, if it is going in this direction, like from right to left, then it will be single direction. If you want to use some values from fact to the dimension also, maybe like from left table also you want some values to the right table, in that case we have to select both. But here I don't want anything from this table to use for the right table, right? So that's why I'm keeping it single. So cross filter direction is very important whenever you want to utilize both the tables from left to right and right to left, then only we can use both. Or else if you're using only one direction, then we can use single only. And this active relationship means when you want to give a relationship between these two, it should be active. Then only your values and your DAX will work correctly. So now let's save this and see the diagram. Okay, you can see here the relationship is formed, and you can see the star is nothing but many values in the fact table and dimension have only one value, and it is going this direction, single direction, from dimension to the fact table. So like that we can create other relationships to the fact table. So I'll just select again a fact table and select the country table now, and I'll just select the region code here and the company code here because both are the common columns having the same common values. So even though title is different but the values are common, right? So that's why we have to select these two, and then you can see it is by default giving many to one and single direction and active relationship. So then save it. So then you can see the second relationship also has been formed. So now our relationships are completed. Now let's see the layout, how it looks. You can see we have these tables which we have used. Okay, so this table we are not using anywhere. So as of now, so we have these tables. Uh, so these tables, both the fact having these relationships, right? That means it is not having any indirect relationship. This is called a star schema. Okay, so for example, if you have another table which is having a relation to a dimension and that dimension is connected to the fact, so that time it becomes a snowflake schema. Let's see that practically now. So just I'll go to the model view again and click on manage relationships and give a new relationship. Now I'm selecting a dimension table of a country and a dimension table of region. I'm just selecting only both the dimension tables. The left table will be the country table and the right table will be the region table. Before that, you can see the columns are not correct. The country is coming in the second line. So which we need to fix it in the Power Query. So then only the headers will be aligned. So let me quickly go to the transform data. So come to the region table. Okay. Then here use a first row as a header so that the column names will show correctly. Then close and apply. Okay, so now let me go and give the relationship and just click on new relationship and select the country table first, then select the region table. So here now the headers are correct. So country and country by default it has taken and it's created. So the relationship is already created. So let's see. Yeah. So sometimes what happen, system will detect if it is having the same name and also many to one, it picks up automatically. So that is the reason it comes. If you don't want auto detected, first remove everything before you start any data model and freshly you can start the relationships. So now you can see the relationship has been created for the country to the region, but this region table is not connected to any fact tables. Okay, so let's see now. Now you can see, okay, so this region having a relation to the country and that country have a relation to the fact table because this is a fact table, right? So this is called a star schema because this is not having direct relation to this fact table. This is coming through a other dimension table and that dimension table is connected to this fact table. So this kind of relationships is called a snowflake schema where one of the dimension table have a indirect relationship to the fact table. So this is about the schemas and the data model. So now the next topic is active and inactive relationships. What is active relationship and what is inactive relationships? Whenever you have a same table with two relationships to the same dimension table, then we cannot have a two active relationships. As per the Power BI, we need to have only one active relationship, rest all will be inactive relationships. Then you may asking why inactive relationship required. So if you want to have two different dates in your fact table and you want to connect both these dates to a calendar date table, then second relationship will be inactive because system will not accept. In that case, if you want to bring the values based on this state, in that case we can use a DAX function called use relationship and get the values based on the inactive relationships. So I will just quickly show you that scenario. So maybe I just go to the fact table and here I can add one more a column. I can say due date is equal to transaction date plus 30. So I am just giving a 30 days due date so that within this date the payment has to happen for these transactions. And for example, you have one table, I'll just add a DAX table. So I'll just go to modeling and create a new table. I can just give a date set table name and give a calendar auto function so that it generates a date table for me. So now you can go and see we have a date table. It has the calendar date based on the data set. It generates automatically because we have used a calendar auto. So now we want to give the relationship to the fact table. So just go to manage relationships and give first I want to give fact table, then I just give the date table. First I want to give a transaction date to the date. Okay, so it is having one to one and both direction because there is no duplicate values in this table. Then save it, or else I'll just keep it save. Then now I want to give a second date also, like I want to give again Q1 and I just select the date column. Now this time I want to select from the due date to this date. So now I cannot select this. It is showing a error like there are ambiguous paths between Q1 and date because there is already existing relationship between these two tables. You cannot give a again a new relationship which is active. So that is the reason we will keep this as inactive just to remove this and then save. Okay. Now let's see here. You can see here it is inactive and it is active because only one relationship is possible whenever you are connecting the same tables. Then second one will be inactive always. So to get the values based on the due date into your dashboard, we can use the DAX function to activate this inactive relationship, that DAX function called use relationship. So I hope you understood all these topics today about the data modeling, and I will come up with more topics in the next videos. Please do like and subscribe. And if you want to understand any new topics, please do comment. And thank you for watching.